Great. So good evening, everyone. I welcome you to the webinar on cost estimation and affordability for your building. I am Yashima Jain, and I'll be moderating today's session for you. Next slide, please. First, I would like to acknowledge the support of the Department of Science and Technology and the Ministry of New and Renewable Energy. I would also like to acknowledge the support of the sponsors and affiliates of Solar Decathlon India. Next slide. And here are our learners who have completed all the 9 self-learning modules. They are Harishwar Reddy, Ireen Shaji, Nalin Bijlani, Nikita Khatri, Prachi Kalathia, Sakshi Lanjevar, and Shia Hamid. Now you all are taking the best advantage of the self-learning modules for your Solar Decathlon India entry, and we congratulate you. Next slide. The slide before this, Jagadeesh. Yeah. Now remember, your second deliverable is due on November 30th, which is Monday, the day after tomorrow. Team leaders will submit the deliverable reports on the same learning platform where you view the learning modules each week. For deliverable 2, there is an additional project details form for each team to fill out. Now this form is in addition to your PDF document. The form is on the Learning Online platform, and we are looking forward to see the progress you have made on your Solar Decathlon India entry. Please remember, the portal will close for submissions at 5 p.m. on Monday. Next slide. Now today's webinar is being conducted by Jagadeesh Taluri, who is a senior consultant at Alliance for an Energy Efficient Economy. He is an architect and an IIM Calcutta alumnus and has over 19 years of professional experience in the design and development of large-scale corporate and institutional projects. He has spearheaded notable projects such as the National Secretariat Complex for the Royal Government of Bhutan and Suzlon One Earth campus in Pune. He was trained in advanced energy simulations and low-energy HVAC design by various international experts at US national labs. Jagadeesh's area of interest are life cycle costing, high-performance buildings, and evolving efficient built forms that suit the Indian socio-economic and cultural conditions. Jagadeesh, we welcome you today. Now today, Jagadeesh will discuss Now today, Jagadeesh will discuss approaches to achieving affordability, different ways of using cost estimation, and how to present your net zero building design to overcome the barrier and the myth that these buildings are not affordable. Now, as always, you are free to send in your questions at any time during the webinar, and we will take as many questions as time allows during the session. With that, it's over to you, Jagadeesh.
Thank you, Yashima. Welcome all. So without further ado, I'll jump into the presentation. I hope all of you have seen the self-learning module on affordability and construction cost estimation. If you have not, that's all right. I'll just briefly cover what we have covered already in the self-learning module. In the self-learning module, you must have understood the difference between project budget, project cost, hard cost, soft cost, and how to do cost estimation, how you do rate analysis and do quantity takeoff for any new assembly that you are proposing, and what are the categories and classifications of project cost estimate. I will be taking you through some examples and case studies in this webinar rather than telling you how you do the estimation. So broadly, this is what you must have seen in the learning module. Every project has capital cost, which is divided into hard costs and soft costs. Whether it's land, civil, MEP, landscape, equipment, and the contingency fund. These are called hard costs, where all the money is used to doing something on the site which you can see with your eyes. The soft costs are the things which are behind the scenes, whether you are paying for the consultant's costs, whether you are incurring pre-operative expenses, the contractor or the client incurs, whether it's for the CER fund, corporate environmental responsibility fund that government mandates you to keep aside, or the financing and interest during construction, financing costs that the builder or the developer will have to incur when he takes loan from the bank. Apart from the hard costs and the soft costs, which primarily go towards capital expenditure, there are operational expenditures, which you incur when the building operations start, whether it's towards utilities, whether it's towards repairs and maintenance, or whether it's towards replacement of any parts or whole of the system. So ideally, you should be looking at all aspects, CapEx, OpEx, and the time that's taken. So your project partner will be asking 3-4 simple questions whenever you are trying to push any net zero energy reform or initiative or any design alternative that is completely away from what they are doing. What will they receive for the money that they're going to spend? And will they get enough profit to outweigh the cost that they are going to incur? And do the returns actually justify they spending the money that they're going to be putting in? And what is the profitability of the investment? So these are the fundamental questions that they'll be asking. In simple terms, nobody wants to spend more. They want to spend as less as possible to get as much as possible. Whether it's, if the builder is selling, he may want to get higher price immediately. If somebody is not selling, if somebody is leasing, they may want to get higher rental yield. If you are owning like an NGO kind of situation, then you may want to have much lower operational costs. So basically, for you, you have to be getting a clear understanding of the entire gamut. Not only the capital expenditure, you also have to focus on the operational expenditure, and you also have to be wary of the time when each of these investments and each of these costs are going to be incurring. You will see all these things in the examples that I will show you in the coming slides. And also the replacement costs and disposal and residual values, all these things you need to take into account. Roughly, I'll show you the financial metrics. This is what it's discussed in the self-learning module also. Whichever scenario that you will be presenting it to your project partner, if you are within the same capex, you don't need to do any justifications. If you are able to make a green building, if you are able to make a net zero energy building for the same capex that they are trying to make a conventional building, then there's no need to justify. But the reality is, how much ever you optimize, you need to spend some more to get better return. So there could be scenarios where you may be spending maybe 2 crore more or 4 crore more or 8 crore more, like the way it's illustrated in this example. And every expenditure comes with certain amount of saving in the operational expenditure. And there are fundamentally 4 or 5 methods people use. One of the most popular method everybody tries to use is the payback period. They say like, okay, you're spending 2 crore rupees more in scenario 2, and my annual OpEx savings is 33%. So which means like in 2 years, I would have saved you enough to be able to pay for the incremental capex. So that's how the payback period works. So you've spent X amount of money. In how much time I am recovering the X amount of money through the potential savings. But payback period is a blunt instrument. If you are trying to do a much deeper look into how you are going to propose your options. Suppose if you are trying to evaluate between having a uh, conventional VAV system, you have done the best you could do, but you're not able to make it net zero ready. You may have to get into using a radiant system, and you may have to get into using insulation and all the other things. For some of the aspects, you may not be able to actually calculate a payback period to the finest degree. So in all those kind of scenarios, usually the life cycle costing is what's going to actually give you that advantage to be able to illustrate to your project partner how you are actually adding value, how it's in their best interest to actually take the proposal that you are giving them. So coming back to the core topic of today, affordability. So affordability is basically not affordable housing kind of thing. Affordability is um, even the rich people also need things to be affordable. If you're pricing an iPhone at 10 lakh rupees, nobody would buy. 1 lakh rupee itself is quite enough. So in the same way, the state of being cheap enough for people to be able to buy. This is the question that everybody is going to ask you, like, how do you make your net zero energy buildings affordable? The conventional thinking among developers or house owners and everything is the net zero energy buildings or green buildings, they tend to cost more because you're putting more quality materials, you're putting expensive systems. So ergo, they tend to cost more. So they won't actually believe that you can actually make a net zero energy building which is financially viable. Most of the time it happens because people are doing energy simulations and approaching the net zero energy building from the ratings point of view, green building rating point of view, where you're basically analyzing your own building against your own building's efficient form. So you have a lot less ability to convince. So now coming to what kind of project partners you have based on the building typologies you have, whether you are doing office building, multifamily housing, educational, or a resilient shelter. Whichever is your project partner, they are going to build and they want to have a low capex to begin with. Their outcome may be same. The office buildings, the developer who's doing the office buildings may tend to own the building and lease it. So for him, getting a higher rental income while having low maintenance is priority. Whereas for multifamily housing, the developers may want to just build the building and sell it off. So for them, getting a higher sale price is priority. In the same way, for the rest of the project partners also, either the low cost or low maintenance is the priority. Now, how you can make your net zero proposal affordable? So there are fundamentally 4 ways in which you can do the tangible ways. A, you reduce hard costs. B, you reduce soft costs. C, you reduce operational costs. And D, you reduce life cycle costs. So reducing hard costs will work well for every project partner, whether somebody is selling the asset or somebody is owning the asset. Reducing soft costs also, I'll explain how you can reduce the soft costs. And operational costs and life cycle costs will not be able to persuade a project partner who is in the mood of selling the project, but still it will make a compelling argument. And you should also be aware of the intangible aspect. The intangible aspect is the one that's going to increase the marketability of the project. The well-designed net zero energy buildings tend to be far more livable. They're healthy buildings. They are not like the normal buildings. And they have far more resilience in case of drought, in case of if your building is cut off from the regular water supply, electricity, or any of the things in case of any event. The net zero energy buildings fare better because they're designed to be resilient. And they also have longevity. The well-designed systems, the passive systems have a much longer lifespan than the active systems. A good designed passive ventilation, passively designed building may be passive cooling for the rest of the lifetime of the building. But even the best of the designed central air conditioning plant needs to be replaced in 20 years. So all these aspects also lead to the increased value of the asset, whether in the short term or the long term. So I'll be telling you about the tangible aspects in this webinar, but when you are pitching for your project partner, you should also be aware of the intangible aspects. In what way, whatever intervention that you are bringing out to the table is increasing the intangible. I'll run you through an example. So for this webinar, I have taken, let's say, office building. I'm assuming your project partner to be a developer with an intent to sell or lease. So his interest would be to begin with low capital expenditure, and he should have a high sale value or high rental value. And I'm also assuming the site area to be 5,000 square meter. I'm assuming FSI to be 2, ground coverage to be 40%, built up area that will come is 10,000 square meter. And let's say the project partner has asked you to say like design a 15-floor building. You may be basically getting these kind of feedback from your project partners already. And this is something they may tell you if you ask them, like what is the period of construction? They may say like, okay, we'll be constructing the building in 3 years. Moratorium is basically after the construction, for a certain amount of period, you don't need to repay the loan. You only pay the interest to the bank so that the cash flows will become better. So he may say like, I have a moratorium period of 1 year or 0. Then usually they can pick up to 30% of the project cost as a loan. They may be picking it up at X kind of interest rate, whether it's housing, they may be picking it up for lower interest. It's a commercial building, they may be picking up for a higher interest rate. Let's assume the repayment period to be 10 years. So I'm making all these assumptions because all the numbers that you will see down the presentation are all based on these assumptions. Now, if I had actually sat with the developer, understood his project, so this is the kind of scenario that this 10,000 square meter building will have. The land cost will be, let's say, all the figures will be in lakhs. Let's say 370 lakhs, and civil works, MEP works, landscape, equipment, internal fit outs, contingency. So if you see, I'd like to draw your attention to one aspect. If you look at the pie chart, all the red shaded things are the hard costs. So if you see the total cost of the project, the hard costs do not account for the entire project. A good number of good percentage is the soft cost, in which if you see the majority of the soft cost, that is IDC, interest during construction period, it accounts for almost 8% of the construction, 8% of the total project cost. And once again, if you see the amount of hard costs in the total amount of construction cost in the total hard cost also, you would see the fit outs, the contingency, and the equipment and other assets account for a good number, and the land also. So in short, your civil and MEP will account for roughly 50% of the total project cost. So trying to convince somebody that the green building is going to cost less is not a difficult proposition. If you see, MEP accounts for only 16% of the total project cost. So even if you propose a system which is going to be 20% higher cost, also you'll be able to justify, as we see in the slides ahead. Now, where and when do you start working on the affordability aspect of your project? I would say you have to start it right away. It's not like you cannot keep waiting till the time, oh, I'll do the design, then I'll try to identify the systems, then I'll get into working on the affordability. No, you have to, it starts with understanding your site, and you have to use simulation as a tool. You cannot rely only on the cost estimates, which are linear. So I advise that you prepare a base case model, which is what I have done for this webinar. And then you establish parameters. Whether your project partner gives you a occupancy schedule, occupancy usage pattern, what's the condition, what's the uncondition, what kind of MEP, what kind of materials he is using. If you have, well and good, otherwise make educated guess, start somewhere. Now, first and foremost way that in which you can reduce your hard costs is it starts right away at the pre-design stage itself, right from the understanding of your building bylaws. So you may have seen that we asked you to ask your project partner, what's the FSI, what's the ground coverage, what's the building, what do you say, bylaws mandate. So if you have a FSI, if you have a ground coverage, so this chart is showing you the number of floors, the bars. So if FSI is 1, if you are allowed 40% ground coverage, if you are using the entire 40% ground coverage, you can exhaust the whole FSI by going 3 floors. Suppose if the government mandates you to do 20% ground coverage, you will have to build up to 5 floors to be able to exhaust the FSI to maximize the built up area. In the same way, FSI 1.5, 1.75, 2, 2.53. So in every scenario, you can go up to certain number of floors. But one aspect that you see in this thing I highlighted in yellow, you require to build 20 floors only in the scenario where your FSI is 4 and your ground coverage 20%. And you may be seeing 20 floor buildings all around, everywhere, where FSI is only 2 or 1.5. Why I am talking about these things? So your builder has told you that he wants to do 20 floors or 15 floors, and this is what your project partner has asked. And as per the building bylaws, the number of floors that you need to build to be able to exhaust the FSI is only 5 floors. Now let's do a parametric simulation. Let's pick any of the parameters. As long as you're using the same parameters, you won't have any issue for the preliminary stage simulations. So even if you are not given exact occupancy schedule or lighting loads or equipment loads, don't sweat it. You can assume any number as long as you're keeping the parameters constant across the simulation. You should be getting the result that I am getting. So right sizing can start even before you start doing the design. So now if you see, I have simulated this building, this 10,000 square meter building in 5 floor form, 10 floor form, or 20 floor form. So as you see, the air conditioning load is changing drastically. The chiller plant size, which is bottom, it's also changing quite drastically. The lift energy changes. So all these things have an impact. Just by adopting the right massing, you'll be able to save your energy consumption by 16.7%. And also you'll be saving the hard cost also. Why? Because instead of 465 ton chiller, you are only buying 344 ton chiller. So that will also result in substantial saving to begin with before you even start the design. So in the same way, like the way we have done for massing, once you have identified the appropriate height of the building that you think will suit for that climate, for your site, for your requirements, you can also run similar parametric exercises on your layout options, orientation options, and further fine tune which direction that you want to go. it will give you a good base to start your preliminary design. Now, another way in which you can reduce your costs is through architectural programming. So this image that you are seeing, each row is one floor. So there are like 5 floors of this building, and each column is a block. So this is for a building that we have designed, where we try to see where to place the cafeterias. The blue shaded things are the cafeterias, and the total occupancy is also given. So in one scenario, everybody is going through the food court, which is at the entrance. So you see the way the corridor is overloaded. And then we try to see like, okay, can we put it this way? All these things are happening on an Excel sheet before we even got to the design. How we split the area program, what the impact. So once we had done these studies, we realized instead of using 6,857 square meter for the eateries, we can get the same functionality in 4,077 square meters. So which means we were able to simply reduce the area that's required by 3.5%, not for the eateries, for the total building area requirement, because we are able to do more from less. And if we had not built this 3.5% area, we would have reduced the total project cost by 3.03%, which is a substantial thing. Suppose had we built the whole project even with this 3.03%, it would have resulted in increased rental revenue, because that much percentage, 3.5% of area, got added to the leasable area. So architectural programming is also one powerful way in which you can actually understand the requirements of your project partner, see where you can multitask, and see where you can right size the circulation areas. You would be able to get a lot more leverage through these. And another way is reducing the hard costs is through civil works. I'll show you one example how we can reduce the hard cost through civil works. Suppose most of the people are going to be using conventional RCC building, column beam. It will take 15 days of deshuttering. And if you are using the conventional column beam structure, to accommodate the HVAC ducts and everything, you'll have to build 4.2 meter floor to floor. This is how the office buildings and commercial buildings are happening. Suppose if you get into a new technology, you may propose pre-stressed post-tension concrete. Sounds very fancy. It requires you to use steel tendons which are specialized, which are high priced. This will give you the ability to reduce your building height to 3.6 meters to accommodate the same HVAC system. And it will also increase the construction time, reduce the construction time. Instead of doing 15 days deshuttering, you will be able to deshutter in 7 days and move to the next floor. So in short, so you are directly getting a 14% height saving, moving from RCC structure to a post-tensioned, pre-stressed post-tensioned slab. If you actually calculate this reduction into your civil works, you will see that your excavation cost may be same, but your RCC work will reduce slightly. Your shuttering work will reduce slightly. Your masonry, not only that, your masonry, plaster, painting, cladding, your glazing, everything is going to reduce because the building height is less. You're building 14% less facade. You're doing 14% less masonry. You're doing 14% less plastering. So even if the cumulative savings are going to be substantial. So just by changing one structural system, you will be able to achieve 6.1% cost saving. And if you look at it in terms of the overall project cost, it will still be considerable. It will be reducing 2.5% of the cost. In the same way, you can also take it further. You can use facade optimization if you actually use parametric studies to right size your window wall ratios. The conventional wisdom says like you do 40% or 30% window to wall ratio. You need not do the same thing. You may say like, okay, I'll put west 0%, east 20%, south I'll do 50%, north I can move it up to 60%. As you see the results of the parametrics here, the air conditioning requirement is much lesser in the last option, even though the windows that I'm putting are much larger on the north and south side. And this will also result in the chiller size reduction also. And not only the chiller size reduction, just in the facade cost itself, it's going to cost lesser than the conventional building that you are doing. So all these things you can account for, and you should account for all these incremental savings in order to justify how whatever option that you are giving them is more affordable. In the same way, facade optimization can go to the next level in case of building materials. One thing everybody thinks is like for you to do a green building, you have to use a very good quality glass, which is soft coated, which is doubly glazed, and which is not actually manufactured in India. Most of the LEED Platinum buildings and TERI 5-star buildings have to import this high-end glass from abroad. Nowadays, maybe some companies have started manufacturing. So if you see in a scenario where there is no shading, the topmost portion is the clear glass DGU. The bottom line, the blue line, is this fancy high-end imported DGU, which is soft coated, which has got SHGC 0.2. In a no shading scenario, you may be seeing a lot more benefit why you are going there. And if you actually do the shading properly, now you see the clear DGU is also performing as good as a SHGC 0.2 glass. So you can make a green building using locally available materials, even clear glass, as long as you do the shading properly, as long as you do your window wall ratios, and as long as you do sizing properly. And with the help of parametrics and simulation, you will be able to more or less correctly find out which option, which combination is going to give you what result, and you will be able to empirically illustrate to your project partner or to your consultants why this is justifiable. If you think what I am saying is a theoretical exercise, let me show you Suzlon One Earth. This building was done by me back in 2005 to 2008. And this is a LEED Platinum building. It has got TERI 5-star, and it's almost 500,000 square feet. It's an office space for 2,500 people. And 75% of the glazing in this building is clear glass. When we tried to apply for LEED Platinum rating, TERI 5-star rating, we had to actually fly the consultant down, build a mock-up, show him, for him to be able to make a simulation model. Exactly. When we were saying like our entire building is covered by louvers, sun will never hit the facade. They couldn't understand till the time we actually got them to the site and illustrate. Then once they understood the SHGC shouldn't be seen at the glazing level, it should be seen at the whole building fenestration level. We were able to fundamentally prove that just by doing clear DG also, we are actually fulfilling all the parameters. And this actually resulted in much better savings for us also. In the same way, on the next level, after you have gone through your massing, layout, orientation, window to wall ratio, building materials, the primary focus that you should be having is on HVAC. If you get your mechanical system right, every other system will become right sized. So I'll be showing you these 5 methods that I have used actively in the last 15-20 years of my building experience. So first and foremost, you should try to reduce the actively cooled areas. The more you can reduce the actively cooled areas where you are actually relying on a active air conditioning system, which like a chiller or anything, if you can reduce it, use that. Second technique that you should be using is to rely less on active means, like how much time you can use passive methods. Third method you try and use is, of course, you have to get into low energy cooling method, whether it's radiant, whether it's chill beams, or whether it's actual passive cooling. And last two methods, which are more important for you to make a net zero energy building, is try and shave your peak loads and try and shift your peak loads. I'll illustrate each of these things so that it becomes more clear. So when I'm saying reduce actively cooled areas, this is also an example of on the right, what you're seeing is Suzlon's site plan, where you can see the white portion is the building blocks. When we were trying to do the simulations and everything, we applied louvers, we applied double glazing, we applied roof insulation, we used LED lights, we also used heat recovery. Despite doing all the things, we could not achieve more than 37% reduction without changing the HVAC system. The developer was adamant that he doesn't want us to get into a radiant cooling system or a central air conditioning system. We had to basically rely on a VRV system. It's a water cooled VRV system. So finally, we sat with the client, we looked at the entire climatic data, then we realized if we push around certain functions into the actively cooled areas, we may be able to passively cool all our lobbies, cafeterias, and everything. So we used indirect evaporation cooling for these areas. So we were able to reduce our energy consumption. So in this, we didn't rely on making the HVAC system better. We tried to reduce the amount of areas that were actively cooled by designing better. And in the same way, suppose you can also look at this aspect, the free cooling aspect. If you use simulation and if you study your existing climatic data with your building design, you will be able to find out how many days or how many hours in a month you'll be able to use free cooling. It's essentially you're taking air from outside, filtering it and throwing it inside. But for you to be able to take advantage of these things, you will have to design your building smartly. Free cooling cannot be used in any building. You have to have a DOAS system. You have to have a dedicated outside air handling system. So fundamentally, you're doing 100% fresh air all the time. So this can, even in a climate like Gurgaon, it can give you easily 10% annual energy savings. And almost 30% of the times in a year, you will be able to use free cooling, which means like you're not activating your chiller. You're basically running your cooling tower and your air handling unit fans just by fan energy and cooling water from the cooling towers. You're able to manage your show. Then other aspect is you get into an actual low energy cooling system. So here I have put two tables. On the left side is a conventional air conditioning system for this 10,000 square meter building. If I was using VAV system, I may have to put 350 ton chiller. That is after I have done all the optimization. I've built a low-rise building, 5 floors. I have done my window wall ratio properly. I have used proper glazing, proper shading. After doing everything, I still will have to use a 350 ton chiller instead of the 480 ton chiller, which we saw before. And to be able to supply the air as per the ASHRAE requirements and other things, I will have to use 9 air handling units of 20,000 CFM each. Then the chilled water piping, ventilation fans and everything. So let's say it costs around 150 rupees a square foot of built up area, not the conditioned area. Now, when I use radiant cooling system, if you see, I'm only buying a 150-ton chiller instead of a 350-ton chiller, because radiant requires much lesser chiller plant size. And not only that, since you are only using air for the fresh air requirement, you don't need 9 air handling units. You can actually make them with 2 dedicated outdoor air systems, 2 DOAS units. So even though the chilled water piping, ventilation fans, and everything is the same, so you see 53 to 39, it has become the chiller size costing. And you will see maximum saving in the AHU side. Instead of 62 rupees per square foot, you are only doing 12 rupees per square foot. And even if you invest in the radiant slab, embedding all the radiant pipes and installation and all the other manifolds that you have to buy, even if you add 55 rupees a square foot also, you still will be spending much lesser, 141 rupees. Okay, so this is what Peter Ramsey was also telling you in the earlier webinar, that the radiant cooled system actually costs lesser, apple to apple, when you compared to a conventional cooling system. But why radiant cooled building costs little more is, it's for me to be able to afford a radiant cooling system, I'll have to bring down the cooling loads of the building to a phenomenal degree, which means I'll have to use a good building, insulation of the roof, maybe facade also. I'll have to use good glazing system. I'll have to make sure my infiltration levels are much lesser. So all these things are going to add up. So those costs are outside the radiant cooling cost. So like I said, it can reduce the capex by 5.9%, a well-designed radiant system, if you compare it with a conventional HVAC system. You'll be building a 57% smaller chiller plant, and you'll also be building 77% lesser number of air handling units. These two result in what? These two result in 1.42% of built up area becoming leasable, because you don't need to use it to do your air handling units. You don't need to use that area to accommodate the larger chiller. So which means you can also claim benefit from your project partner. I'm giving you 1.42% more leasable area, which is going to result in additional revenues. You also account for that profit while you are looking at the cost benefit analysis. And another aspect that you can do is shaving the peak load and shifting the peak load. If you look at this chart, this is for the 24-hour consumption, 24-hour cycle. You look at the blue area and the green area, that light blue, where it says chiller cooling, where it says tank discharging. So this is the cooling load profile. If you see around 6 o'clock in the afternoon, 6 o'clock in the evening, the peak load that I have is 1790 tons, which means I'll have to have a chiller which is 1790 tons at least to be able to cater for the cooling requirements. But instead of doing that thing, what we can do is, like, what the system we have designed for this building is, we will not be using the chiller plant between 12 o'clock in the afternoon till 6:30 in the evening, where my load is higher. The chiller plant is essentially going to be shut down. What we are going to be doing is, like, we are going to be running the chillers after 6:30 in the evening till 12 o'clock in the morning, when the climate is benign, when the tariff is lower, when conditions are optimal, there's no occupancy. So in that time, we'll be running the chiller plant. We'll be buying a smaller chiller, 865-ton chiller, and we'll be running it through and through at 100% capacity, while we'll be recharging the thermal storage tank. So that is going to give me the benefit of not using the chillers. I'll be able to withdraw the cooling from my thermal storage tank during the daytime when I have much higher requirement. and manage my show. But putting a thermal energy storage tank, as you see in the table on the left lower corner, a radiant cooling system may be costing only 151 lakhs. A conventional system may be costing 161 lakhs. But radiant cooling with thermal energy storage is going to increase your hard cost, increase your capex to 179 lakhs. But if you see the life cycle costing, if you see the benefit that you will accrue because you're not running the chiller during the daytime, you're not buying this big chiller, and you're also running the chiller plant when the power tariff is lesser, when the power demand is lesser, you will be having a life cycle cost which is lesser than even radiant cooling. Ergo, you'll end up justifying using the thermal energy storage. So these are the fundamental ways in which you can potentially reduce your hard cost, soft cost, or use life cycle cost to be able to justify the kind of intervention that you're bringing to the table. And now I'll talk about the soft cost aspect. Is there a way that we can actually reduce the soft cost? Whatever intervention that we are doing, is it going to affect the soft cost? So if you see this interest during construction and the contingency itself account for 12% of the total project cost, which means even if you are able to make slight reduction here also, it'll give us offset to be able to afford that installation system for which we are not able to do a payback period calculation probably. So for example, if I had used a steel structure instead of a RCC structure, you remember my project partner wants to do the building in 3 years. But let's say if I propose a steel structure, which is hybrid steel and concrete, whereas I'm able to maintain the thermal mass also, I'm able to put a radiant slab also, and I'm also able to reduce the construction period to 14 months. The 14 months is including the design. So I'll reduce the construction time by 45%, and which means the building operation can start 1 year before than what the project partner is accounting for. So basically that is going to result in IDC costs reducing by almost 30%. So all these aspects you'll have to take into account to be able to justify the net zero energy building that you are doing. So this is what I was showing you. Like on the left side is a conventional building with a good VAV system, the concrete building. On the right side is a steel plus radiant steel building with radiant cooling. So if you see the MEP work straight away, even though civil costs has increased, the MEP works have decreased by 8.7%. And the contingency amount has decreased because the capital costs have decreased. And if you see the IDC cost has decreased by 44%. Instead of 675 lakhs, you're only accounting for 377 lakhs. The total project cost came down by 7.3%, just because we went from RCC to steel, and we are able to do the whole building in 14 months instead of 36 months. So if you account for the time value of money, if you account for the interest during construction, if you see how the builders are going to be using their funds, you will be able to basically do a advanced building with advanced construction system, advanced air conditioning system at a much lesser price. So I will give you one other interesting case study. You may have seen Irad building being quoted by several people, right, in the earlier webinars also. So this is a building that's done by Ashok Lal, and he has done both the phase 1, phase 2 himself. So phase 1 is a conventionally, it's a good quality building, even phase 1. It's done with all the passive techniques, and it's shaded properly, it's insulated properly, it's sized properly, it has got good daylighting. All the principles are there, but still it's a air conditioning system which is VAV, the conventional variable air volume system. So the peak cooling load of this phase 1 is 91 tons. The phase 2, sorry for the typo, on the right side is the phase 2 that they were proposing. For this, the designers calculated 49 tons as the cooling load. But what was happening is the phase 1 actual chiller size, that chiller that was bought was 150 tons chiller, because of the oversizing aspect, which consultants get into, because people use thumb rule calculations or simple calculations to design the HVAC, or they may not have used the peak load shaving techniques or something. So the building, when they were doing the phase 2, the designer, when they actually simulated, when they actually looked at the existing load patterns and everything, they realized the actual cooling load is 91 tons peak, whereas the chiller is 150 tons. And when they actually assess the combined cooling load, peak cooling load of both the phase 1 and phase 2, it's 135 tons. And the combined average cooling load is only 85 tons. Now, for phase 2, they didn't even need to buy a chiller, technically speaking, because the combined peak load is only 135. They could have potentially used the 150 ton chiller to cool both the buildings, which is exactly what they had done. So what they had done was they bought one 85 ton chiller to cater to the average cooling load. So they made the existing 150 ton chiller as a redundant chiller, as a failback. If one chiller is going under maintenance, the other thing will be there. Now, with this 85 ton chiller, they connected the phase 1 air handling units. The 85 ton chiller was supplying chilled water at 7 degrees centigrade to phase 1 building. The chilled water comes out of the phase 1 building at 9 degrees or 10 degrees centigrade temperature after losing the cooling. Now they used this 12 degrees or 9 degrees centigrade water and mixed it with radiant slab of phase 2, supplied chilled water to phase 2 at 15 degrees centigrade. In essence, they were using only 185 ton chiller to cool both the buildings. The chilled water was going to phase 1 to cool that building air handling units. Then whatever water was coming out, it's getting mixed and going through the radiant slabs of phase 2 building. So in essence, they've actually managed the entire show with only one chiller, 85 ton chiller. The existing 150 ton chiller, they use it only 7% of the time when the actual peak cooling load hits, or when the 85 ton chiller is under maintenance. So HVAC is the key. Even the well-designed buildings can also become oversized. So focus on your simulation techniques and simulation studies. You will be able to right size the building. Right sizing is the key. Right sizing comes right from how you are massing your building to how you are actually leveraging your area programming to how you are actually sizing your air conditioning system, how you are reducing your loads. Right sizing is a phenomena that you have to see completely. Okay, so with this, Yashima, I'll end my webinar. We can take questions. Should I stop sharing my screen?
Yeah, sure. Thank you, Jagadeesh. And we've had questions coming in during the webinar, and
Okay.
let's take them one by one. Yeah. So the first question is, on which software do we do simulations for costing?
there's no costing simulation software. Basically, you use Excel fundamentally. Should I share my screen and show the Excel sheet?
Yeah, absolutely.
So there's no, you don't need to rely on any software to do the simulations. You just get the, so this is a simple Excel sheet. Are you able to see my screen?
Yes, Jagdish.
Yashima?
Yes, we are able to see your screen.
Hello?
Hello? Yes.
Yeah. So
yes,
if you see,
your screen is visible.
This is the conventional building with RCC structure. And on the right side is the steel structure. Yeah. Right side is the steel structure. So all the things that you need to do, you can do it in Excel. Basically, you get the sizing aspects and parameters from your simulation software, and you can use Excel to do the things. You don't need to get into any specialized software for costing. If you see, there are none, because you may be using several simulation tools and techniques to get the relevant information to feed into your Excel model.
Right. Yeah. Okay.
Yeah. Next question.
Do you want to go through the spreadsheet as well right now?
Yeah, we can go through the spreadsheet.
Okay.
So this is basically the detailed spreadsheet of the example that I showed you. The conventional RCC building with good VAV system versus the advanced steel structure, concrete steel hybrid with a radiant system. So as you can see, excavation side, there may not be any difference. The RCC work, the RCC aspect will be lower, and the shuttering aspect will be much lower because it's a steel building. The shuttering is much cheaper, and the structural steel aspect will be more. Masonry also cost will reduce. The plastering cost will reduce. So if you see, we have done the entire detailed understanding.
Right. Yep.
So what gain that you will see is when you size your HVAC system properly, when you are using small amount of chillers, it will also result in substantial savings in your electrical system also. Instead of buying 10 DG sets, you will be buying only 2 DG sets. Instead of buying X size of transformer, you will be buying much smaller size transformer. So it will result in a lot of other savings. So basically all these savings will be able to give you the additional benefit to be able to use the irrigation system, to be able to build that rainwater storage system, to be able to build that solar system, to be able to build that IBMS system. So whatever you have saved, you will be able to use that money to get all these systems which are not accounted for by the project partner, and yet come up with a decent sized building. Even if you cost little more, because if you see 1828 was the basic building, and in this, with all the bells and whistles, including the roof garden and insulation, my building cost is 1868. This higher cost I'll be able to justify very easily because I'm reducing the interest during construction. I'm also doing the building a year faster, which is I'm also giving more leasable area. So even if you go a little higher also, you will be able to justify everything.
Right. Thank you, Jagdish. Another question we have is, in what unit can we calculate the affordability of the structure? Also, for individual dwellers taking loan for the structure, what all factors could be included to convince him that a green building is more affordable?
What unit can we calculate the affordability of structure? Listen, the only unit that you can use is what your project partner knows, cost per square foot. Ultimately, you have to translate everything into cost per square foot. Even if you have seen in my Excel sheets also, everything is getting translated to that. And secondly, individual dwellers taking loan for the structure. See, whether it's an individual dweller, whether it's a, what do you say, a big contractor, the fundamental question is the same. What value is your intervention bringing to me? Is it going to increase my asset value? Is it going to reduce my operational cost? What am I going to get for this building in the next 10 years, 20 years? So basically, as long as you are able to calculate your life cycle cost, if you have done a decent building, you'll be able to justify. I have not seen any green building which is unaffordable yet in the last 10, 15 years, if you design it properly. And the fact is that
you add something here. Huh?
Yes,
yeah,
yes, please.
Yeah, after Jagadeesh is done. Jagadeesh, you were saying something after you're done.
No, you can add, Prasad. I can.
Okay. So in the self-learning
what
module,
I was telling is.
Yeah, go ahead.
No, what I was telling is the factor that you need to see is only 3 factors: whether you are reducing the capex, or whether you are reducing the opex, or whether you are reducing the life cycle cost. These are the 3 fundamental factors. Yeah, Prasad.
Yeah. So I'm trying to interpret the question and saying that maybe what the questioner is asking about is not necessarily the unit, but maybe the metric. And so in the self-learning module, there's a description of different metrics under which you can show affordability. And payback period, life cycle cost, return on investment, internal rate of return, all of these have been described conceptually. So these give you an idea of the various financial metrics that you could use to be able to show what, how it might be beneficial for your project partner or the entity that you're trying to show affordability to. So you should take a look into that in more detail.
Yeah, Shima.
Yep. Yep. Thank you, Prasad. All right. Next question, Jagdish. Would the costing spreadsheet be available to participants if they say that an example would be helpful?
Okay, I can provide the template that I have showed you guys in 2 days. I'll send it to you. You can share it with the participants. Only caution that I'll give you is this thing: use the techniques, not the costs. The costs that I am using are they may be dated, they may be relevant to certain building type, they may be it varies from state to state. You should always refer to your project partner's brief for the base costs, or you refer to schedule of rates, government schedule of rates.
Right. Thank you, Jagdish. Next question. So how should we establish a typical cost for our project?
How should we
establish a typical cost for our project?
Typical cost for your project. So it's basically this thing. First, you understand your building bylaws, you size your building properly, and you start with a proper building area program. Building area program is the key to be able to start with a costing. Once you have that, then you can do proper estimation of your, what do you say? You can take the quantities, you can take the quantities using the physical quantities using your drawings, and you can rely on your simulation models to be getting the cooling loads and the electrical loads and the water demand and everything. The water balance calculation that you can use the templates provided by, I think Sanjay Prakash also has given the water balance or water load calculations, right? So using all these things, you can create a typical requirement and typical cost for your project. Okay, and you don't need any extraordinary expertise to do the cost estimation. Basic cost estimation fundamentals are same: length by breadth by height multiplied by unit price. You don't need any more complicated formula than this for doing any costing.
Right. Thank you. Next question. So in the beginning of the session, for educational buildings, the two criteria were low maintenance cost and low capital cost. If we show our project partner that the capital cost will be high, although life cycle cost is much lower, will it deter them from using our recommendations? What is your view in this regard?
Ideally, it will not deter because the education institute is going to own that building forever. One of the advantages of the green building is it's not only the lower operational cost, it's also the replacement cost is also lower, and it also going to occur after a longer time. So instead of they replacing the HVAC system in 10 years, they may be having to do it after 30, 40 years. So life cycle costing, if you do it properly, it will be a compelling thing for your project partner.
Right. Next question. What expertise do we need to do cost estimation? We are undergraduate students.
See, the only expertise that you need is like, see, you have been given all the tools. So basic cost estimation, you can, the quantity of civil works, you can do it from your drawings. And the civil engineering members in your team will be able to assess the requirement for what do you say, RCC or your foundations and everything. And if you are able to simulate the building using the design builder software, which you guys are familiar already, you will be getting the sizing requirements for HVAC from there. You don't need to be a mechanical engineer to be able to do the cooling load calculations. You should be able to do it from the simulation model.
Right.
And after that thing, combining everything into a simple Excel spreadsheet, that should give you.
Okay, thank you. Next question. In the name of cost reduction and demands of the NGO, is it possible that we do away with HVAC and compressor-based systems completely? Our site is in a remote area. The people do not use HVAC systems anyways, and they have a higher.
Hello, Yashma, I couldn't hear you. I
Yes.
lost half the sentence.
Yes. So I'll repeat the question again.
Okay.
In the name of cost reduction and demands of the NGO, is it possible that we do away with HVAC and compressor-based systems completely? Our site is in a remote area. The people don't use HVAC systems anyway, and they have a higher comfort range.
See, first and foremost, nobody is pressuring you to use HVAC. So we have done many buildings which actually don't need HVAC in most climates. So if you can do away with HVAC, please do away with HVAC. So if you have higher comfort range, then I don't understand. Is there any question that I'm missing, Ashima?
No, it's there on the, it's there in the Q&A tab.
Yeah.
Yeah, that's the question that I just spoke out.
May I add something here?
Yeah, please, Prasad.
Yeah. So the competition expectation is that you are able to provide thermal comfort to the occupants. You can provide that either by using passive means or by using active mechanical HVAC systems. That's totally up to you. The expectation is that you have to use the thermal comfort range that is in the National Building Code. If, however, your area has people who have a higher thermal comfort range, it's going to be up to you to convince the jury that that is the case. So you'll have to provide evidence and you'll have to make a case for that.
Right. Thank you, Prasad. All right. Next question. The examples you showed were multi-story buildings. If our building is of 1 or 2 stories only, what opportunities will we have?
Okay. In the webinar, there's only one example I have shown of multi-storied buildings versus low-rise buildings. The initial slide where I'm looking at the FSA aspect the impact of building height. All the other slides that I have shown, where I have shown window to wall ratio, where I have shown the structure advantage, where I have shown VAV versus radiant thing, they are using the same 5-floor building. So it's a 5-floor building window wall ratio to 5-floor building window wall ratio. It's a 5-floor building cooling with conventional air conditioning system to 5-floor building radiant cooling system. So you have all the opportunities. Barring massing, all the other techniques that I have discussed in the webinar will be applicable whether you are doing a low-rise building or even a single floor building.
Right. Yeah, so I think those were the questions that we have had, and we'll wait for another 2 minutes. If someone wants to ask any other question, you can do so. Yeah. Anything else you would like, any piece of advice, Jagadeesh, that you would like to give to the participants?
See, piece of advice is this. Have fun with simulations, because ask questions, start early. You don't need to wait for the affordability exercise till the time you do the building. The conventional way the architectural system works is they say like, okay, first let's do the design, then we'll identify the materials and other things. Perspectives hone ke baad, then we will sit and do the costing, and then we will figure out what happens. Then we will go to the structural guy, conventional HVAC guy, etc. But when you're doing net zero energy buildings, the process starts from day zero. You are looking at optimization and right sizing. You're not looking at costing and affordability. You're looking at, am I figuring out or am I sizing the requirement optimally? If you ask the right question, you get the right answer. That's the only thing. And second is, do not get bogged down by the simulation engines, because you must have seen like the slides that I have showed you today rely on information that I have taken out from at least 250 parametric runs, if not more. So the idea is not to make a complicated architectural model for simulation. Simulation models need to be simplified, and the simpler you make your simulation model, the better you'll enjoy the process. It's like you don't need to have any expertise. You do 1, 2, 3, and then you just compare. You'll know which way to go. Like take one thing at a time.
Yep. And meanwhile, we have had a few questions, so we'll take them up now.
Yeah.
The first question is it necessary to compare our design with conventional building to prove our design is affordable?
You have to start with somewhere, right? Of course, you will be comparing your building with whatever building that your project partner would have built if you had not done the net zero energy building that you are proposing. If he has 10 crore rupees, if he is going to make a particular school, so that is what you are going to compare it with, the 10 crore rupees, whatever his budget.
Right. Next question, how do we tackle post-construction maintenance cost? What are the various strategies which can be used for that?
Post-construction maintenance cost. Okay, is there any more to that question?
No, that's about it. If
okay.
So it's,
if the participant can ask what exactly he has in mind.
Yeah.
Because there's no way you can eliminate the maintenance cost. What you can do is you can reduce the maintenance cost. If the more passive you use, passive has lesser maintenance than any active system. And if you have smaller sizes, it'll also have lesser maintenance cost. So 10 chillers will have more maintenance cost than 2 chillers.
Right.
We'll not be able to eliminate the whole thing, but we'll be able to reduce the impact.
Yeah. Next question, what all things can come under target market as we are doing a community resilience shelter?
Target market. Okay, the only thing I can think of is like what you are doing with the community resilient shelter in the event when there are no calamities. So on a day-to-day basis, how you are using the community resilient shelter to create sources of revenue, to create that corpus. So are you using it as a marriage hall? Are you using it as a exhibition space? Are you using it as something else? So this has nothing to do with the what do you say, costing aspect, but sometimes your project partner may not be able to tell you what the target market is, but if you understand the location, if you look at what's happening around, what social and economic aspects are not being catered within the 800-meter or 1200-meter walking radius, you will be able to create functions like that and then take advantage of it.
Yeah,
Right.
I want to add something here.
Yes.
This actually is a really, really good question because it throws up the other side of affordability, which is that on one side you're trying to reduce costs, but just as Jagdish mentioned, you have the ability to also identify areas to increase revenue. And whether it's a marriage hall or something, if you are able to understand the community around and identify what the community needs, then you'll be able to make a case that your project partner may not be aware of using the building in a way that adds to the revenue of either the project partner, the community center operations people themselves, or even to the community itself. And that becomes a really good story for affordability. Because normally as designers, you would never be looking at the other side of programming the building to create more value. And the points that Jagdish made were really, really good from that standpoint. So I'm glad somebody brought this question up.
Yep. Thank you, Prasad. Next question. Is there any project you would suggest to do life cycle costing for our green building as a case study or benchmark?
Is there any project? Is he asking for case studies?
Yes, yes. Any case study which they can look at for reference?
See, there are lots of buildings within India that you can see. You can see the buildings done by Sanjay Prakash. You can see the buildings done by Ashok Lal. Irad is a very good example. Irad Phase 2 is a good example. It's a small size also. And they have used all possible techniques, whether it's right sizing the building, or whether it's using advanced air conditioning systems, whether it's using free cooling, whether it's using shading. And it's also done in a very elegant and affordable manner, using as much locally available materials. Even shading is also done very brilliantly. Irad is one. You can even look at any of your, what do you say, old buildings also. Like even the TERI campus is also earth tunnel cooling and other things. Sanjay Prakash's Agilent building is also good example, where they are using the techniques for all the water conservation. So water is something that Sanjay Prakash has done very nicely. You can also look at Infosys building that's done by Peter. Peter also has showed where they have built two blocks. One is a conventional HVAC system, which is optimized to the teeth. And second is a radiant system, which is optimized. So that's one really good example. And there is a lot of material available on that Infosys Hyderabad building. And if you want to look at thermal energy storage and what benefits it offers, they can see Nirlon. Nirlon, it's a building in Worli in Mumbai. So that project uses thermal energy storage, chilled water tanks to a phenomenal degree to cut down their air conditioning system.
Right. Yep. Thank you, Jagdish. Yes,
so,
Prasad.
I believe that the General Service Administration, GSA, which is a government agency in the US, has provided actual life cycle cost case studies of how life cycle costing is done. and you could look that up, and do a search for that. If it's possible, we'll also try to find that case study and include it amongst the additional resources in the self-learning module.
Right. Thank you, Prasad. Jagdish, one last question for today. It's more of an HVAC related question. So, is desiccant system with evaporative cooling or a ground source heat pump a good choice for cooling system?
It is a good choice, but you have to understand the context. Suppose if I am trying to use this for a residence where there are 5 occupants, it may work very well. But if I am trying to use this thing in an office building where there are 200 people, the system may break, because you have to see the desiccant systems have limited ability to take out the moisture. So you have to see the sizing aspect. With ground source heat pump, it's like, for example, if an office building has 400 square feet per person, fairly less occupied office, I may be able to pull it off. If it's located in maybe in a benign climate like Pune or or Bangalore, or if the climate is hot and dry, mostly, you're only taking out the sensible, whatever moisture generated by sweat evaporated by people, because people add a lot more moisture even on a hot and dry day than the actual humidity from the weather. So that is one aspect that you have to see when we are getting into these kind of system. But on a 450 square foot per person office building, I may be able to pull it off, but I'll not be able to pull it off on a building like Infosys where the loading is like 75 square feet per person, or a BPO where 35 square feet per person in 3 shifts. So the systems break.
Right. Yeah. All right. And we have another question. So it's more of an administrative question. So the question is, what's included in the second part of the submission for Monday? So the second part of the submission is a form where you have to fill in your project details. It is available on the Learning Online platform. So your team leader would have access to that. And there are very basic details about your project, which we would like you to fill up. And yeah, that's the second part of the submission for Monday. And with that, thank you so much, Jagdish, for a very informative session today. And I hope our participants have made the best use of the knowledge and practices you've shared with us today. And thank you everyone for participating. And we will see you next week at 4 p.m. for the webinar on resilient design.
Yashima?
Yes, Prasad.
Just a very quick thing. Again, I want to kind of acknowledge the way in which Jagdish showed all of his case studies. This was an example of being creative. It was an example of saying that there are ways of looking at your building and thinking about your building that are innovative. They may not be innovations in terms of new technologies, but they are innovations in terms of the way you integrate your systems and you understand how they impact each other. So once you are able to see those and once you're able to understand that, it becomes a very creative and innovative approach to cost estimation as well as to showing affordability. So normally we think of creativity only in terms of design or in terms of technological aspects, but this is another way of being creative. And it's a very important aspect of being creative for Solar Decathlon India. So I wanted to just acknowledge that and thank you, Jagdish, for some really, really cool examples.
Yeah. All right. Thank you, Prasad. And thank you, Jagdish.